is equal to mu s times n. So these are the two relationships that you have. On mu s is the coefficient of static friction. And you can see from this graph here that you have mu s is greater than mu k. Example of these values would be, for instance, 0.4 for mu s and 0.3 for mu k. That's what there is to know about friction. It means that when you have static equilibrium, you can say that the force of friction, when you're in this case, the force of friction is going to be less than or equal to mu s times n. But it's always less than the maximum. And when you have motion, it's equal to mu k times n. The mistake not to make is when something is in equilibrium, to say that the force of friction is mu s times n. So the maximum values that it can have is mu s times n. And when it is in motion, it's mu k times n. And times n, not times the weight. So here it turns out that the normal is equal to the weight, but that's not always the case. You could have the block on an incline, and in that case, the weight is not equal to the normal. So it's always mu times the normal. So that's a review of what there is to know about friction, and we can use that here. So if you look at the problem, you see that they talk about motion. Mu must be then the coefficient of kinetic friction, and you can use that relationship for this problem. So the key here is to draw free body diagrams that are correct. If you have them down, then you'll be good. You can solve the problem. Let's draw the free body diagram for B. I'm going to do the weight. What else do you have?
The normal force.
The normal force. The labeling here maybe is important. Let me do it. So here it's a way of B by the Earth. Then you have the normal force acting on B by what? By A.
There's tension.
There is a tension force acting on B by the rope.
And there's a force of friction acting towards the left.
And there is a force of friction acting on B to the left and by what?
By A.
By A. And it is kinetic friction because there is motion. Okay, that's for B. Now let's do A.
You have two normal forces acting on it.
So I'm going to do the weight. I'm doing the easy part. And then, so what do you have acting on A?
Normal force by B and normal force by ground.
Okay, so the normal force by the ground is up, okay? And what about the normal force by B?
It's pointing down.
It's pointing down. So there is a normal force acting on A by B. What else do we have?
Friction point to the right.
Friction. How many forces of friction do we have? Two, because we have two surfaces that are in contact for A. One surface which is in contact with the ground, and one surface that is in contact with B. We have one force acting on A by the ground, force of friction, and another force which is a force of friction acting on A by B. And finally, we have the force P. lots of forces you see acting on B, on A. It is important to count them all correctly. Now we can use the third law of Newton. Can you find forces that are related by the third law?
Friction.
NBA on
You have this one, friction on B by A, and there is also friction on A by B. These two must be equal in magnitude, they're opposite in direction, and just because of the labels. You can see that they are related, but they are not on the same free body diagram. That's what we are saying yesterday. We have also, that's what you said, Declan, NBA and NAB. So these are third law pairs. We have to find the acceleration of A, because of course B is not moving. So if B is moving, is not moving, why can I claim here that I have kinetic friction?
Because the surface on which it rests is moving.
Exactly. So what counts is the relative motion of the surfaces. And as long as you have motion there, you get kinetic friction. But we know that B is not moving, so we can use that to say,
that is in static equilibrium.
okay, so what does it mean for the forces?
That they all equal, the summation of the forces equals to 0.
Exactly. So we can say that the tension is going to be equal to the force of friction. The weight is going to be equal to the normal. There's something else we can say here. What relationship do we have between two forces on this free body diagram?
Friction is proportional to the normal force.
Exactly. So we can say that F BA is equal to mu times N BA. We have that. And of course, it's going to be mu times WB, because the normal is equal to the weight. So that's very nice as a relationship because it gives us the value of that force. We know this one now. Let's do A. So what can we do for A?
We can substitute this second normal force at NAB for the weight of block E.
Exactly. So we know that we have NAB is equal to NBA, and NBA is equal to WB. So this is because of the third law. This is because of the second law. We know that there is no acceleration along the vertical. We know also that we have F kinetic AD. It's equal to F kinetic dA, which is equal to mu WB.